All right, so now we're looking at something called row echelon form. I did mention it earlier, but row echelon form is what happens and what it's called when our augmented matrix is finished. So in that prior problem, our augmented matrix, we ended up with 1, -1, -1, 7, and 0, 1, -4, -5, and then 0, 0, 1, and 1. And this right here gave us that triangle, that triangular form, but it also put it into row echelon form, where you are decreasing in power, you're decreasing the amount of variables each time, and your leading coefficient, so that's the one all the way to the left in that row, is a 1. So we call that a leading 1. So if you end up with a 2, you're going to have to figure out how to scale it down. Now, if you have 2 rows with non-zero entries, the leading 1 in the higher row is farther to the left than the leading 1 in the lower row, because this is farther up because there are more variables with it. Now, if you have any rows that fully cancel out, those automatically head down to the bottom. So we will see that, but first let's go ahead and we're going to look at if these rows, I'm going to give you a couple of rows, are in row echelon form or not. So here are your 3 rules. Definitely write those down with this piece, so pause it if you need to. These are all in your book. This is actually on page 367 in your book, but obviously me explaining them to you helps a lot more than you guys just sitting there reading the book in silence. So go ahead and write those down, pause it, and then we're going to head to the next video to do some examples.